Okay, so the next section that we're going to do lesson 12.3, which is comparing populations. We're going to use dot plots to compare two different populations by taking a random sample of each population and comparing the samples using dot plots, which we've used quite a bit, so hopefully you're starting to get a little bit more familiar with them. Alright, so it says a test prep company gives its students a pre-test before the course and a post-test after the course is completed. The test prep company picks a random sample of 10 students from each testing session. So we're going to make a dot plot for the sample of the pre-test scores, and we're going to make a dot plot for the sample of post-test scores. So we're going to do just like we did before. They've already numbered it for us, so all we need to do is plot our points where they go. So we need a point at 520. 510, 550, 580, 600, 480, another 480, a 460, another 460, and a 640. It's just that simple, guys. You take the dots that they give you, the data that they give you, and you put the dots on the number line where they go. So for the post-test, again, they put the numbers for us, so we just need to fill it in. So we have a 510, a 480, a 510, a 610, a 590, a 670, ooh, there's a good one, a 550, a 560, a 600, and a 610. So now I don't know how these are graded or anything about them, but what we could do is we could look at these and see how do these compare. Is it better? Is one better than the other one? Do we see any change at all? Okay. So C says compare the dot plots. The plots have similar, is it center or spread? Well, let's see. They're both spread out about the same. This one goes from 460 to 640, and this one from 480 to 670. So they're not exact, but they're pretty close. Their centers, however, are not that close at all. So they have a similar spread, but the post-test values are shifted to the right. Notice that these are kind of centered over here to the left, and there's just kind of one here and there, but most of these are kind of shifted over here to the right. So, your reflection question, go ahead and pause the video and answer your reflection question. It says, what can you infer about the populations by comparing the dot plots for the samples? So come up with your inference, and write it down, and then come back to the video and you can check it with mine. Okay, welcome back. I say that the pre-test scores were lower than the post-test scores. Just something that simple. The pre-test scores were lower than the post-test scores. So hopefully that's what happened. Hopefully after you go through a unit or a lesson, you want your scores to get better. That's kind of the point. So, on to the back. We've got explore activity number 2. So we're going to use box plots to compare populations this time. It says a survey of 7th graders asked girls and boys how many baseball caps they own. So we're going to make a box plot for the number of baseball caps girls own, and we're going to make a box plot for the number of baseball caps that boys own. So, remember, first things first, we really need to put our numbers in order from least to greatest. So, we've got 3, 4, 5, 6. Let's see here. We have 2 7s and 1, 2, 3, 3 8s. 8, 8, 8. So for boys, let's see, our lowest is going to be 7. No, 8, but we have 1, 2, we have 3 9s. 1, 2, 3. Let's see, 1, we have 2 10s. we've got 112, 115, so I'm getting a little crooked here, and we have 2 18s. So now that we have our data, we can get our box plots created. So remember, we need a dot at our lowest and highest values. So our lowest number is going to be 3. We have 1, 2, 3. Dot. And my highest is going to be 8. So 5, 6, 7, 8. Next thing I need to do is I need to find my median. So we're going to cross out. We've got 3, 8, 4, 8, 5, 8, 6, 7. We've got one number in the middle. So our median is going to be 7. Now we need to find our lower quartile and our upper quartile. So we've got 3, 6, and we got two numbers in the middle, so we have to find the middle number, which is going to be 4.5. So let's see, 4.5 is going to be about right here. And then for our upper quartile, we've got 7, 8, and we have 2 8s in the middle. So 8, 5, 6, 7 is going to also not only be our highest value, but it's also going to be our upper quartile as well. And like we saw in the other video, that sometimes happens. That's just what your data shows. You have to do what it says. So then we connect our box plot to our whisker. Next set of data, our lowest value is going to be 7. Our highest value this time is going to be 18. Quite a bit different than last time. So now we need to find our median. Let's cross out. We have 7, 18, 9, 18, 9, 15, 9, 12. And in the middle we have 2, we have 10. So that is our median. And something that I just noticed, I have made a very large error. I completely left off the number 18 from our girls. So I am going to have to change my data. No! So we'll go ahead and finish the box plot for the boys, and then we'll go back up and finish the one for the girls, since I have made such a large error. Hopefully some of y'all caught that and were thinking, wait, Ms. Robertson, slow down, you messed up. But that kind of happens sometimes. It's not a secret. We all make mistakes. So let's pick up this one, finish it off, and then we'll go back and we'll correct the other one. So let us do our lower quartile. We've got 7, 9, and then we have 2 9s in the middle here. So there we go. And then over here we have 12 and 18. We've got two numbers in the middle that are not the same. So we need to average them. We have 15 plus 18. So 8 and 5 are going to be 13. And that is going to be 3. So now I need to divide that by 2. That's going to be 1. Is 2. Subtract, get 13. It's going to be 6, which is 12. So I need to add a decimal and a 0. Bring my 0 down, and this becomes 5. So our upper quartile is going to be 16.5. Let me draw my box. Now I can draw my whisker, and we can go back and fix our box plot for the girls. Alright, so let's see how much it changes. Let's see, obviously I know I need to put a dot way out here, 16, 17, 18. So let's see how much we need to change up here. We know our lowest value is going to stay the same. Let's check our medians. So now we have 3, 18, 4, 8, 5, 8, 6, 8. So instead of 1 7, we get 2 7s. So either way, we're still the same on that one. So we don't have to change our median. Our median is good. Let's check our lower quartile. Oh, everything is good here. It still stays 4.5. Let's check our upper quartile. So we have 8, 18. We're left with these 2 8s, which is still 2 8s. So even though I made a nice big error, it didn't work out that bad for us. So it actually ended up working out itself. So now we actually have 2 completed box plots and we can move on. So it says, compare the box plots. The plot for the boys has lesser or greater range. Well, it goes all the way from 7 to 18, but the girls goes from 3 to 18. So it actually has a lesser range, but it does have a greater interquartile range. Notice how much bigger our boxes, remember our IQR, our interquartile range, is just from the top of the box to the bottom of the box. It's not the full range, it's just the boxes itself. So the middle 50% of caps was less spread out for the girls. It would be for the girls. All right, so take this information, pause your video, and answer the reflection for problem for number 2. And when you come back, I'm going to talk you through it. All right. So what can you infer about the populations by comparing the box plots for the samples and justify your answer? So I would say, now this is going to be kind of long, so you're just going to have to compare what you put with how I would word it. I would say something like, boys tend to own more baseball caps than girls. It's kind of not a secret at this point. It's pretty normal for a guy to have more baseball hats than a girl. About 50% of the girls own 7 or fewer caps, while the boys own about 7 or more. So that's a pretty big difference there. The maximum value of 18 is the same for both groups, although this does appear to be a pretty big outlier for the girls. Notice it's the only one. And when I was crossing out my information, I just completely skipped over it, which hopefully you did not. Hopefully you caught my error and will say something. So, moving on. The next page is use statistical measures to compare populations. Ooh, big math words. Y'all watch out. So, it says you can use the means and ranges of 2 random samples to compare the populations that the random samples represent. Paula and Daniel wanted to confirm or determine the average word length in 2 books. They took a random sample of 12 words each and counted the length of each word from each book. So calculate the mean for book 1. Well, what we have to do is we have to add up all of our pages. So they started it for us. We have 3 plus 7 plus 5 plus 2 plus 4 plus 3 plus 1 plus 6 plus 4 plus 8 plus 2 plus 3. And remember, we divide that by however many numbers we have. So we're going to divide this by 12. When you add it up, you end up getting 48 over 12. And remember, a fraction is just a division problem. So 48 divided by 12 is going to be 4. So the mean for book 1 is going to be 4 letters long. So we need to find the range for book 1. Our highest value is going to be 8. Our lowest value is going to be 1. So our range is going to be 7. For step 3, we need to calculate the mean for book number 2. So, once again, we're going to add them all up and divide by 12 because we have 12 numbers. So, 5 plus 4 plus 3 plus 6 plus 4 plus 5 plus 5 plus 2 plus 3 plus 4 plus 2 plus 5. Ooh, that was close. Almost finished the box. And divided by 12. So then we end up getting also, 48 over 12 again, which equals 4. So the mean for book 2 is also 4. Now we need to find the range. Well, my highest number is going to be, let's see here, 6. My lowest number is going to be 2. So my range is going to be 4. So now let's answer our questions on the bottom. It says, you can infer from the mean of each population that the overall average word length for book 1 is either less than, the same as, or greater than the average word length for book 2. Well, look at our means. They ended up being exactly the same. So it's the same as. And then it says you can infer from the range of each population that the length of the words in book 1 varies less than, in the same way, or more than, book